Hello everybody, and welcome to our very first developer office hours. This is a hangout created for us to just kind of get together and chat as developers. We're going to do it every other Wednesday from 3 to 4 p.m. Pacific time. We're hoping that time slot works for as many people as possible, but that may change in the future depending on what kind of response that we get. And the idea behind these office hours is for us to just kind of talk about some things that are affecting the developer world these days. Generally speaking, we'll probably have some structured content in the beginning like we will today, but hopefully we'll be bringing some people in for interviews and just some roundtable discussions down the road. And at least in the second half of the hour, we'll have just open Q&A. Anybody that wants to come in and ask questions, if they have topics, it can even be code level stuff you want to talk about. Just be a group of developers in a virtual meetup, just kind of hanging out and getting stuff done. So today we're going to start with some structured content. This is our first of the series, and we're also recording some of these. So just be aware these will end up on YouTube if you couldn't make it the first time around. We will be posting these to our website and to YouTube down the road. If you have a specific topic that you'd like us to talk about, whether it's criticism related or just general mobile stuff, an issue even that you have, send those requests to marketing@crittercism.com, and we'll work with you and maybe put together a show just for that topic. We're very open to ideas. This is going to be kind of an experiment for us as well, so we'll see how it goes. And today we're going to start off with a very hot topic. We've been talking about it a lot, or rather the Crittercism crew has been talking about it a lot. Wearables, watches, and apps. So the Apple Watch came out this past April, and it's kind of stirred up a lot of things in the wearables market. So me as a developer, I want to answer the question, why should we care about the Apple Watch? What does it mean to me? And I'm also going to go through an open source demo that I have put together. It's going to walk through the basics for an Apple Watch, and I'll even send you a link so you can go and download it yourself and have your first Apple Watch app up and running in just a few minutes. And finally, as we'll do every week, we'll have at least about half the time at the end for just some general questions about wearables, about anything you want to talk about. And of course, this is pretty relaxed, and we'd love to hear some questions throughout. So if you want to use the group chat to kind of raise your hand almost if you don't feel comfortable butting in. Otherwise, just feel free to talk over me if you've got something you'd like to discuss as I go through the content here in the beginning. And first, a little bit about me. Your perfectly amazing host. I'm the lead developer at a company called Whitewater Labs. We're a very small development shop, and I'm based out of Charleston, South Carolina. I've been developing iOS and Android apps for as long as they've been able to be developed. I started with the first iPhone back, I think it was 7 years ago now, and developed a long series of apps. Most recently, I worked on an app called KeepSafe. They're a nice, successful little startup in Soma over in San Francisco. They've got about 50 million downloads now. Now I'm with Whitewater Labs, and we're working on a number of fun new apps. So I'm pretty excited about that. And why I work with Crittercism. Crittercism has been one of my favorite products that I've used as a developer, and I've put them in every single app that I've developed since about 2012. So I'm a big fan. I can't say enough good things about Crittercism, so that's one of the reasons that they are happy to have me kind of lead these office hours for them. So a couple words about your amazing sponsor. None of this would be possible without the good folks over at Crittercism. Their team has really driven a lot of this, and I'm just here to talk about dev stuff. So they've done a lot of the infrastructure and getting all this set up for you guys, and I couldn't be happier to be working with their team in this way. So what Crittercism does, a quick pitch on their behalf. They are mobile app performance monitoring. So I'm a fairly savvy developer, at least I like to think so. But I hear that and I wonder, okay, what the heck does that mean? So I like to break it down something like this. What happens if I'm a developer, I launch my app out in the App Store, people are using it, and then all of a sudden it starts breaking, or it starts running slow, connections are dropping, and the worst of the worst is crashes. What happens when an app crashes? And back in the early days of the App Store, it seems like decades ago, even though it was only 4 or 5 years ago, you're left in the dark unless a user tells you. So in my first apps, I would see a lot of things that looked like this. These gnarly 1-star ratings in iTunes saying, hey, your app is crashing and I don't know why, fix it. And me as a developer, I look at this and I have no idea what to do with this. I mean, I know the operating system because they say it in the comment. I don't know what device they were on. I don't know their account. I don't know the context around why it's crashing. So as a developer, the best I could do is try to figure out their username and find them on Twitter or something like that. And then the best case scenario is I ask them, hey, what happened when my app crashed? And they say, I don't know, I think my iPhone's just broken, or the app just sucks and I hate you. So as a developer, this wasn't a real solution to these problems. And crashes are going to happen, so that's what Crittercism is solving. It's a small SDK that you pop into your app. It's one framework and it's 2 lines of code. You just import the framework and initialize it, and you're good to go. It automatically monitors for all these crashes, all of these exceptions, and they've got some awesome features that they've developed over the years that can help you debug your app remotely and see what kind of performance bottlenecks your app might be running into. And I really can't say enough about what these guys have done for me and my apps. And as one example, when I was working at KeepSafe, this was years ago, and we were launching an app between iOS 4 and iOS 5. We were launching a new update. And me being the terrible tester that I am, I did not fully test the app on all the operating systems that we supported. And I accidentally put a method in that only is supported by iOS 5. So lo and behold, Apple goes through and they are able to test it and it works, and they approve it for the App Store. The update goes out, and every single person using the app on iOS 4, it started crashing for them. And me as a developer, I would have never known until I saw these nasty 1-star reviews in the App Store. But fortunately, I had Crittercism already plugged into the app, so I got these nice alerts right to my email saying, hey, the app is crashing for, it was something crazy, like 75,000 users or something like that. And I was able to figure out the line of code that it was happening at, able to figure out exactly what was going wrong, and quickly debug the issue, and had a hotfix out through Apple within a couple hours. So that in and of itself, for me, is totally worth it. And like I said, this was years ago, so they've added different service layers on top that just make it a great product. So that's all I have to say about Crittercism. They're used by a ton of huge companies. I wish mine was up here, but I'm not quite big enough for that yet. Hopefully someday. But these guys are really, really good at what they do. So definitely check out their framework. So getting back to the topic of the day, I would like to talk about the Apple Watch. And unless you've been living under a very, very large rock the last few months, you know that Apple just they invented this beautiful new watch, and it's the first thing to ever do this, and it's the awesomest thing ever. But we've seen this before, right? I mean, if you look at the iPad or the tablet PC, first introduced in 1988 by this famous fellow, Bill Gates released the tablet PC in 2002, and it wasn't that well received. Nobody really cared. By the time 2010 rolls around and Steve Jobs introduces the iPad, it's the hottest thing since sliced bread. Finally, in 2012, when Microsoft relaunches a tablet, launched the Surface, everybody thought it was stolen from Apple. And we're seeing the same kind of thing happen with watches, not quite to the extent that we saw with the tablet, but Nonetheless, Apple is really stealing every other smartwatch's thunder just because they are Apple. It's happening here, and I'm sure it'll happen again with whatever they come up with next. But the fact of the matter is, these watches have been around for a while. I mean, Pebble, they're a mainstay. They've been around for a number of years. 2013, I think they started. And they are, in developer circles, they're a great, great watch. They're hackable, they're customizable. They're very loved within kind of the nerdy communities, I would say. Same thing with Android Wear, but they were able to bridge the gap a little bit farther because Android is such a prevalent operating system. More people were exposed to Android Wear and kind of understood what it worked with, how it worked, all this type of stuff. But still, that was only just a year ago, and it never really hit the mainstream. And now, of course, we've got Apple Watch, which just launched here in April, and it's taken the media at least by storm, and people are really starting to take notice of smartwatches. So whether or not Apple has the best technology is yet to be seen, but you can't fault them for bringing a product to market as well or better than anybody else in the world. So I'd like to frame this all in the context of developers. Why should developers care now? Me as a developer, why do I care that Apple came out with this watch when these watches have been around for so long? Well, it's always good to look at some numbers. So these, just bear with me here for a second. They are probably not the sole reason behind Apple Watch's rise, but they give a little context from a developer perspective on why things are happening the way they are. So if you look at this chart, we've got the number of Android Wear compatible devices. What that means is you've got the correct phone that will be able to pair properly with a smartwatch or an Android Wear device. And we've got a timeline here. This is in kind of the European standard. So we've got January, February, March, April, May. These are every month between January of last year to April of this year. And we're seeing a very, very slow adoption. I mean, we started at 10%. Over the course of a year or so, we kind of moved up, and they just crossed the 50% margin within the last couple of months. So now, over the course of a year, we've seen there are about 50% of Android Wear compatible devices out there in terms of phones. This is a fairly slow adoption curve, and it makes sense if you look at Android from a broader perspective, because if you look at their phones, right, if you look at the operating system on the phones, we see very slow rollouts. If you've got an Android phone yourself, you might be stuck on Jelly Bean or KitKat, and you want the latest and greatest, but your device may not support it. And that's just the nature of the beast. I mean, that's the devices that are being made for Android have various degrees of memory, of CPU power, of all of these things that are required to run the operating system. They can't hit full saturation of their latest OSs until the devices catch up. So this is really no surprise. Nobody expected Android Wear to take off overnight. We kind of expected this slow linear curve. But with Apple Watch, it's a little bit of a different story. If we look at the time frame here, we're talking days. So we're talking April 10th, April 12th, 14th, etc., all the way to around end of May. And out of the gate, Apple Watch was compatible with about 35% of all iOS devices. So all iPhones that were out there had enough power to properly work with the latest iOS and in turn the latest Apple Watch. And this was back in end of May, so by now they've definitely crossed the 50% threshold, and this is only going to get better. So Apple, just because of the ecosystem that they manage, they're able to control rollouts and kind of get people into their new devices and into their new features much faster than you can on Android. And again, this is something that we see with the phones, just like it's mirrored in Android between Wear and the phones themselves. But the biggest number, the biggest thing you need to pay attention to when you're thinking about, okay, should I develop for Apple Watch? It's just looking at units. How many people are wearing these devices? If we look at the first year of unit sales, Android Wear, their official numbers were somewhere in the 750,000 range of total units sold. Obviously, Apple Watch, it's still way too early to tell. And to be quite honest, I think sales are much lower than everybody expected, but we're still seeing estimates that within the calendar year, they'll be able to sell 18 million Apple Watches. Let's say they miss those estimates by 50% and they get 9 million units sold. That's still an order of magnitude higher than what Android Wear was able to do within the same time period. So this is the proof right here that Apple is able to ship more devices, get it in more people's hands than any other smartwatch manufacturer. And this is the reason that we as developers need to start paying attention. Because if you're developing for Android Wear, especially in the beginning, you're targeting a very specific audience. 750,000 people is not a big audience when you're when you're trying to distribute an app and probably monetize an app. If you're talking about 10 to 20 million people, that's a real audience that you can get in front of and start to monetize, and it makes your investment in developing an Apple Watch app worthwhile. So if you throw everything else out, these are probably the numbers that you need to look at. It's just the kind of saturation that you're going to see from the Apple Watch. Is it culturally relevant, and are regular people outside of my tech circles actually wearing and using this thing? And we'll see how that progresses over time, but so far, even if they miss estimates, it's still looking like it's a worthwhile platform. Okay, any questions so far? I'm going to take a pause here and just kind of slow things down. No? Alrighty. Moving on. I guess everything I'm saying is absolutely perfect, and I love that. This is my favorite slide in the entire deck, and it's an XKCD comic. Why develop for the Apple Watch? Because everybody's doing it. And this depicts it perfectly. If all your friends jumped off a bridge, would you jump too? And if you really think about it, what if they have a good reason for jumping? Right? I mean, is the bridge on fire? Is something happening where all of my level-headed friends are jumping off of a bridge? I probably would follow them. This isn't quite an extreme example, but if all of these big companies are embracing Apple Watch, doesn't it make sense for you to do the same? And it's not just small startups. It's not just the bleeding edge tech companies. It's these big behemoth industries that have already embraced the Apple Watch. They've already had their apps out there since day one. And they know that this is going to be a big market. And they have understood that the investment is lower than building an entire app from scratch, because building an Apple Watch app is essentially like building an extension for your main app. So the monetary investment, the time investment needed for an Apple Watch app is much lower than it is for an actual app. So that's been another big help in all these big industries embracing the Apple Watch. So we see companies like SAP in the SaaS space. These guys, they're hooking up all their cloud applications with watch components. They're putting their guys out in the field. They're putting Apple Watches on all of them for demos and for statistics and all the things that they need to do. They embrace it from day one, and we're going to see a lot more companies jump on board. Finance, the same thing. You can get credit card alerts, PayPal alerts directly to your wrist when there are new charges. Anything that you might need from these guys, you can at least see notifications, at least see glances from your Apple Watch. Travel is one of the big examples, and we see a lot of fun demos with travel. For example, SPG, Starwood Preferred Guest, they have a watch app that you can not only check into your hotel, but you can also wave it outside your door, and it'll unlock the door for your hotel without ever even having to check in. You can do that all from your Apple Watch app. And American Airlines, you can show your boarding pass, you can see your gate, all this type of information can be piped right to the watch. And these guys all had their watch apps out day one. Finally, brick and mortar. These are historically kind of slow moving on the tech side, but we've seen so many companies embrace the Apple Watch already, especially with Apple Pay. You can go up and buy your coffee, buy your groceries, just by swiping your wrist. And it's a really slick technology that so many of these big companies have embraced so quickly. So it's been fun to see from that perspective. Okay. So now hopefully you're convinced that whether you're a small startup or a big giant company or maybe a consultant for one of these companies, hopefully you're convinced, okay, maybe it's time to at least kick around the idea of making one of these apps. What does it take to build an Apple Watch app? Well, fortunately, it's already done for you. Not quite, not 100% done for you, but you can at least see a nice example here at one of my open source projects on GitHub. Check out this link here. We'll also distribute these materials after the Hangout's over. Or ping me anytime. You can find me on Twitter, LinkedIn, all this good stuff. But it's a nice little demo. You can download it immediately, and there's even a link within the README to a full tutorial that walks you through every step that you need to make a full Apple Watch app, and even some extra fun extensions beyond that. So go to this link. This is going to be the basis for the next part of the presentation. I'm going to walk through a quick demo, and this will be the code that I'm basing it off of. So you can get a high-level overview through this demo. And if you want the nuts and bolts, go check out that project. And within the README, go see the full tutorial. First, I want to say a quick note about how, generally speaking, Apple Watch apps work, particularly with managing payload, managing cloud connections, all this type of stuff. So we've got our Apple Watch sitting over here in the corner, and we've got our cloud services. Any kind of APIs that you have, your own servers, backends, third-party APIs that you need to connect to. As of now, you can't connect the watch directly to the cloud. And if you've done your research, you also know that Apple Watch does not have GPS embedded in it, nor does it have cell phone service embedded in it. So what that means is the Apple Watch needs to leverage the iPhone to get all of this good stuff to it. So what that means is the Apple Watch will send a request to the iPhone. The iPhone will perform some function, whether it's crunching data, gathering GPS location, or pulling data from the cloud. It'll do all the heavy lifting, and then when it's done, it'll push that data back to the watch. And the watch will be able to render it into a nice display or handle user input, whatever needs to be done. But this is the general flow for piping data in and out of a watch app. So we'll check out a quick demo that kind of reinforces this general flow. Give me just 1 second. I'll pop open Xcode and get everything set up. Any questions in the meantime while I'm getting things prepared? We have a very enthusiastic audience today in this first office hours. Don't be shy. Let me get this WatchKit app fired up. I think it's already configured, as every good demo should be, properly prepared. And all we're doing now is just building and running our WatchKit extension. So this is going to pop open our simulator. And here's our watch display. And we're going to open the helper app on the iPhone. When you want to open an Apple Watch display, it's pretty easy. You just go to Hardware, External Displays, and you can select one of the Apple Watch sizes. And what we're doing in this demo is very, very simple. This is not by any means a nice polished demo. but it's a great first step. You can understand how these flows work and understand how the code kind of communicates back and forth to get your own app spun up and ready. So the main iPhone app, all it's doing is tracking my current location. And we are able to do that through the simulator, through the debug menu, location, and we're simulating a freeway drive. I think it looks like they're going up the 280 over in the Bay Area. But the main iPhone app, it's showing my speed, my current latitude, and my current longitude. That's it. The Apple Watch app is showing these ugly little pins as I'm driving up the highway. And it's also showing my current speed, and you'll notice these update every so often to match what's here on the main iPhone. We've also got this big giant crash button in there. For the sake of this demo, just ignore that. And I would highly suggest not putting a crash button in your Apple Watch app. This is really only good for demo purposes. It's not great usability to have a button that crashes your app, so stay away from that. When we want to look to see what's happening between these two, we can jump back into the code. And we're going to start with the main view controller. So the main view controller, if you're familiar with iPhone development, is just running the iOS app here on the right. All that we're doing when we initialize that view controller is setting up a location manager. And what that's going to do is just figure out where we are. It's plain and simple. We're going to set a delegate, and when the delegate receives a location, when the device says, hey, I know we're here, it's going to shoot some coordinates back to these methods down below. And you'll notice here in our update method, whenever the location changes, we update our text in these labels. So like I said, this is a super simple demo. Anytime the location updates, it's updating these labels here in the iPhone. Easy enough, right? So how do we get this information over to the watch? Well, if you go through our full tutorial in the README of the open source project, you'll see how you can add these WatchKit extension targets to your app. And we've already done that here, so we won't go through that process. We'll just say, take our word for it. We'll show you how to do it in our full tutorial. But you can do things like changing the interface. Here's where we put our map and our crash button and our label. It's all pretty similar to the things that you've seen for developing for iOS. So back to our code. This is code that will run in the WatchKit extension. This is our actual watch code. And it's pretty simple to walk through. I'll make some correlations here as we go along. We have this awake with context method. And think of this as like a view did load in your regular iOS apps. So the WatchKit extension is being woken up. We need to initialize things and get things moving so the user has a good experience once the app does finally open. So all we're doing here is just initializing our Crittercism SDK, and we're requesting the location from the phone. To reinforce that, when the Apple Watch app actually opens, and this is kind of like the view did appear method, let's say on iOS. So the WatchKit extension activated, this method is called by the operating system. And what we're doing here is initializing a timer. So every 10 seconds, we're going to request the location from the phone. And what that's doing is every 10 seconds or so, we're pulling the information to the watch. So you notice it's not in real time, but every 10 seconds you'll see a little refresh and you'll see the speed update. This is the method that drives that. And for Apple Watch development, there are a lot of timers that are happening for real-time apps like this. It depends on how you want to kind of build the architecture for your app, but if you haven't used NS timers, get used to them because they are a great way to kind of rapidly update your app's user interface on the watch. So when we want to request the location from the phone, this method is called here, and you'll notice this method right here is WK interface controller. What this is doing is calling our parent application with some dictionary request. And this dictionary can be anything you want it. We just structured it in this way for the demo. But this API is provided by Apple, and it's the way for you to communicate between your WatchKit extension and your core iOS app. So we're going to open up our parent application and send over this data. On the iOS side, on the core app, we just implement this delegate method. Handle WatchKit extension request. So all this method does is take in our dictionary and say, okay, what should I do with this request? What we want to do in this demo is get the serialized location. So we just want to get the location from the phone, from the GPS on the phone, and then send it back to the WatchKit extension. And we do that through our view controller. This is, again, all on the phone side. In our view controller, we get the latest location that we can and convert it into a dictionary. And we need to convert it into an NS dictionary because that's the only data type that the WatchKit will understand so far. It's not good at serializing full classes, especially custom classes. So we need to make it properly encodable. Think about it like encoding it into JSON. If you can package it as JSON, then you can send it from the phone to the watch. So that's exactly what we're doing here. We're sending the latitude, longitude, and speed back over to the app delegate, and the app delegate calls this reply method. The reply method sends the data back over to the WatchKit. So if we go back into the WatchKit, you'll notice this reply block here. This is an asynchronous method that goes from the watch to the phone, and as soon as the phone sends a response, this block is called. And what we do there is we parse the location. So we just grab all of the coordinates and the speed out of the dictionary, and we update our user interface on the watch itself. And this is all that it takes to go ahead and update the watch interface. Pretty simple. It's only, maybe we went over 50 lines of code or so, and you're able to request data from the watch to the phone, package up data on the phone, and then ship it back over to the watch. You can do that in just a few methods as we've shown here. And again, it gets more detailed in our tutorial if you're so inclined, but hopefully this gives you a general idea on how all of this stuff looks from a code perspective. One last thing I want to make note of is we are logging our Crittercism errors here. If this request does fail, we want to know about it as developers, especially if this app is live out in the field. Users somewhere are out using our app and something goes wrong. We want to know about it, so we're handling this exception. We're kind of catching it and saying, hey, our code understands there's an error. This isn't going to crash the app, but we still want to know about it, so report it back to Crittercism. And how this looks in Crittercism is something like this, a nice handled exception. They've got a great dashboard. You can go and see all of the handled exceptions that have occurred, how many have occurred, how many users are affected. This is a great way to prioritize your work as a developer. And if we drill into one of these puppies, we can see, okay, the application delegate in the iPhone never called reply. So we sent out this method, and we never got a reply response. That method just timed out, right? So think of it as the connection just dropped. We weren't able to wake up the iPhone. We weren't able to communicate with it properly, so something bad happened. As a developer, if this is happening a lot, and it probably will, you might not know about this until you see it in your Crittercism dashboard. So you might want to handle this in your code, in your user interface. Say, hey, we couldn't wake up the phone. Maybe it's not in range. Make sure it's in range and please try again. That's a lot of words to put on that tiny little lock screen, but it's a nice way for you to know, okay, we need to handle this in the UI so the user isn't just left hanging and nothing happening. They also handle crashes. So if you remember my not so clever crash button here, it triggers an exception, and we are able to see that exception here in the dashboard. Any uncaught exception will be sent directly to Crittercism so you can see what exactly happened. In this case, the reason behind the exception was, well, I put in a button that crashes the app, so of course it's going to crash. You can also see a full stack trace of methods leading up to it. This one's not symbolicated, but if you upload your dsym file, this will be nice, pretty method names for you to debug what exactly went wrong. They also have breadcrumb trails for you to see the steps that were taken that led up to the crash. And these are great for helping you replicate any issues that you see come up that you might not be able, that might not really, you might not know as a developer what exactly happened. So being able to reproduce it is always a great win. And some of these are directly from Crittercism. They do automatic breadcrumbs for major events, but you can add your own. So if the user clicks a button, if the user performs an action, you can log your own breadcrumbs and they'll show up in this nice trail for you to replicate any crashes or exceptions that occur in your app. And the last thing I want to note here in the Crittercism dashboard is transactions. So they've kept up with the SDK very well, and they have full WatchKit app support. What that means is they automatically monitor the connection between your WatchKit extension and the iOS app. So you'll see that here in the watch communication transaction. I just implemented the one line of code to initialize Crittercism, and they are automatically watching for any failures that occur in that watch communication. And this is another great way for you to figure out if there are connections dropping, why are they dropping, and what can I do about them as a developer. And they're able to do that right out of the box with no extra configuration on your end. And I'm hoping that they'll continue that trend as watchOS 2 comes out. And I suspect that their support for this is only going to improve as Apple Watch's OS improves as well. So again, just a great tool for you to monitor the performance and monitor any issues that are occurring in not only your iOS app, but also your WatchKit extension. Okay, so mostly that demo worked. I'm fairly happy with that. Are there any questions up until this point? No? Alrighty then. So if you remember our diagram here, we start with the watch. It requests data to display, as we showed in that single asynchronous method. The phone does some stuff. In our case, it got the latest GPS location, packages up that data, and then sends it right back to the watch for display. And if you've been paying attention to WWDC last month, you might have heard that Apple Watch is coming out with their OS 2. They've got a preview out now, and there are going to be some fairly sizable changes already. So it's exciting as a developer to see that they're going to be rapidly iterating on all of these things and really listening to the developer as time goes on. The first big thing that they're introducing is that code will run natively on the watch. Currently, it runs as an extension. So technically, it's running on the phone, and it's only using the watch for updating the display and doing some very lightweight things. But in the next iteration, your code will run natively on the device, on the watch device, that is. So you'll be able to do direct-to-Wi-Fi communication. Any known Wi-Fi hotspot you can make a direct connection with without being near the iPhone. And this is going to improve battery life tremendously, not only for the watch, but also for the phone. Probably more so for the phone. And that's because on the watch, it doesn't need to waste CPU cycles trying to wake up the app on the phone and then transfer all the data back and forth. It can cut out the middleman and go directly to the Wi-Fi. This is also going to cut out that extra step that's needed in communication. So when the communication drops between the watch and the phone, it won't really matter as much because you're able to go around the phone and directly to Wi-Fi. And it's going to be much faster as well. If you don't need to wake the core app up on iOS on the phone, then you won't need to wait on the watch for that all to initialize. So the biggest thing that they've been seeing at Crittercism, and as just a user of the Apple Watch, is that the apps are generally very slow to start, sometimes painfully slow. And that's because they're trying to talk to the phone and then provision resources on the phone and then finally do what they were asked to do. So by not relying so heavily on the phone, the app itself on the watch is going to speed up tremendously. So we're all really looking forward to this direct to Wi-Fi communication. And let's say the watch is collecting user input or user feedback or doing something that's gathering data, and then it needs to send it back to the core iPhone app to send it up to the cloud or do some processing with. The next version will have peer-to-peer file transfer in a sense that the app on the iPhone won't need to be open. So again, we're solving the same issues where we can bypass the app and just start doing things on the watch. Once we're done with them on the watch, we can package up a little file and send it over to the iPhone. Next time the iPhone app launches, the file will be made available for processing. So it doesn't need to wake up the app again. It doesn't need to process the file on the spot. The watch can just send it over for the iPhone to process as it sees fit and once it has the opportunity to do so. So again, this is going to speed up the watch performance and improve battery life on both sides. So we're able to, at least in one sense, we're able to bypass this type of flow. This will still be the core flow when you need to do things like talk to cell receptors and talk to GPS, because the watch doesn't have either of those yet. So you can still do this, but we'll also have this option as well, where the phone doesn't need to be the connector. You can talk directly from the Apple Watch to the cloud, prepare data on the Apple Watch, and then send it over to the phone in a more efficient way. That's all I have for my structured content today. We've got some time left over for open-ended Q&A and discussion. In the meantime, stay posted not only with Crittercism, but also with the open source project that I demoed here. We'll be definitely updating that as OS 2 rolls out and as new features are made available. And hopefully I'll be coming up with some new tutorials as well. I know the folks over at Crittercism are working on an Android Wear tutorial as we speak, so if you're not an iOS guy, if you'd rather dive into Android Wear, that tutorial will be made available from what I hear in the next couple of weeks. So I want to thank you so much for listening. I hope this was maybe not entertaining, but hopefully helpful in your development for Apple Watch and convince you that this is a real market. Hopefully I'll see you here in a couple of weeks for our next office hours. Thanks so much for joining.